All right, now that I finally got the recorder started, the things that you need to know is that some of your Khan Academy due dates were extended to February 3rd, based off the fact that we hadn't made it far enough this week for you to finish those. And then I assigned new Khan Academy, because remember, we're still doing the Khan kickoff competition. So some people are coming to me saying, I'm all done with Khan Academy, assign more. Like, give me the next week's homework. Not give you extra work, but they're caught up on their work and they want to access the next stuff. Because they're being really smart and they're realizing that once things get busy in quarter 3, you might want to take a week where you don't do as much math homework and you catch up on other classes. Like, I get that. So if you work your way ahead, that's a really good strategy for then being in a good place. Yep. I got Nason, I got Grant, I got Caroline, I got Samaje, I got Leah, I got Sophie. Huh. That's so funny. The guys working here disconnected the PA system. So go and get your computer out. So Desmos.com. Now, guys, I want to make sure that you understand what we're doing in that first one there. We're looking at what Gabriel and Kayla have, and we're looking in total. I know at one point in CPM, you looked at like equation maths where you set things equal to each other. This is not that. This is asking, what does Gabriel have together in total? How might he write it? Right? How might he talk about what he has all together? And then Kayla looks like she kind of grouped hers differently, right? Instead of shoving them all in one big group, she left them separate. So what everybody should be doing right now, and only Nason has done so far, is typing in what you think the expression would be to represent Gabriel's amount and to represent Kayla's amount. Megan, what might be a good idea next time is try to go to lunch try to go to the restroom during lunch. So I need you to get to Desmos.com, like, quickly. Like, we got to get caught up because you're a few minutes behind now. And then, after you've completed slides 1 and 2, go ahead and make sure that your notes have a header on them of, ooh, that's a little zoomed in, equivalent expressions. Equivalent? That's weird. It is Desmos.com, right? Not Desmos.org. Desmos. Oh, you demos. Desmos. There we go. And then log in. Top right. Equivalent is a hard word until you realize it's like our stem, right? Equivalent. V-A-L-E-N-T. So please make sure that your notes are headed with equivalent expressions, which when I go to spell it, I have to say it like equivalent. So log in at the top, and then when you go left side student activity, or so anytime you log in, you're going to go there. See the student homepage? Should be the top one that pops up. Equivalent expressions. Sunny. That's correct, what you wrote, but we want to be efficient and probably combine those like terms. So you're fine. Don't go back. You do not need to go back. You do not need to go change anything. But we're normally going to use coefficients for variables, and we're going to group together our constants with each other. So I'm going to actually pause the activity for a second so that you guys are definitely writing with me. In your notes, for Gabriel, right, Gabriel, how could we represent what he has in total? Maurice, go ahead. 3x plus 6. Please write that down in your notes. That is an expression until we put an equal sign, then it kind of becomes an equation. Yeah, it's working. But then, move on to slide 2. Here, I'm going to unpause you guys once you have that written. Move on to slide 2. Think about how Kayla might represent her amount. She's got it split up, right? In like 3 different groups here. So, what we're practicing today is viewing things in groups. Kayla, and I know I'm moving a little fast because I have to. I don't have much time today. I only have you guys until 12:36, which is like 15 minutes from now. Kayla might write her expression like 3 groups of x plus 2, which is exactly the same, right? We can see that it's the same quantity when we think about what do they have in total. It's the same quantity, 3 x's in total and 6 in total, because if we do multiplication and say what is 3 times x and what is 3 times 2, when we have 3 groups that each have x and 2, it's the same. So this, and some people wrote things out like this, like x plus 2, x plus 2, x plus 2, or some of you wrote x plus x plus x, plus 1 plus 1 plus 1 plus 1 plus 1, like, that's fine, that's right, but it's not efficient. Remember, we want to be efficient here. So if you're still looking at 1 or 2 or 3, let's move on from those slides. And actually, so everybody, I'm actually going to pace you to slide 4. So it's going to jump all of you to slide 4. And then I'm going to pause you. So everybody should be looking at slide 4 except for the Nason who slipped up to slide 5. It's fine. So I don't know why this picture is not showing up. I'm going to try to cut it again. When you look at that group in total, how many total A's do we have? 8. How many total B's do we have? 4. So I'm going to unpause you. Obviously, we want to click on 8A plus 4B as one of our options there. But I want you guys to take a moment and click on what other options you think would also represent what we have there. When you think you have selected all of the possible options, why won't you show? Oh, there you go. Show anyhow. This is our next vocab word to write down. And guys, I'm going to start taking my notes a little bit differently so I don't write all the way across the paper so that you guys can see more. You know what I mean? Because if I write all the way across the paper, it's harder for you guys to see it. So the next vocab I want you to write is up here. Distributive property tells us when we multiply by an expression or multiplication by an expression, distributes to all parts. Does anyone know what it means to distribute? Yeah, give, right? Like if you work in distribution, you give things. You like deliver things. You take things. So to distribute means to like split up, to give to multiple people. So if we look at this group, and well, distribute kind of means to split up in a way, right? Like to give out. If I split this up and look horizontally at the rows, I want you guys to still be trying to complete the Desmos. Like once you have this written down, go back to working on Desmos. Only a couple people have selected what we could do here. If we split this into 4 groups, like horizontally across, would each group have the same thing? Yeah, right? What does each group have? 2 A's and a B. So if we split into 4 groups, please write this down. What the distributive property actually helps us show is the number of groups and what is in each group. So if we look at it as 4 separate groups, each group has the same thing. It's got 2A and a B. Please make sure that you write down number of groups. I'm using the hashtag symbol, right, but it actually means number. It was number before it was hashtag. Please write down that each group is what's in the parentheses. So, if I have 4 snack boxes, right? We have snack boxes available for you guys to take home for remote days. And if each snack box has 2 apples and a banana, right? I have no idea what's in those snack boxes. But if each snack box had 2 apples and a banana, all 4 of those snack boxes, let's say you got like 4 boxes worth, you'd have 8 apples and 4 bananas total. But can I cut a banana in half? So if I wanted to split this up to not just be 4 days, but, well, what if I'm really hungry and I decide, we need to write down another definition before I keep going about the food. Are we good with this right here? Does anyone need more time with this? Which question? Give me just a minute, because this might answer your question. What I'm about to show you. Factoring. And this is actually the last vocab word for today. Factoring. So notice, it's obvious. It's underlined. I'm going to go ahead and highlight it too. Factoring means breaking something apart. Technically, mathematically, that would be division. When we break something apart, that is division. So my question to you is, okay, my 8A and my 4B, we saw that we could break it up into 4 groups. But could we just split it into 2 groups? Yeah, couldn't we just cut it like across the middle? And if we cut it across the middle, how many would be in each group? 4 A's and 2 B's. Right? If you split that right across the middle, two groups, each group would have 4A and 2B. Now I'm going to show you a couple more, right? The one we just did, 4 groups. We said 4 groups or 4 boxes would be 2A plus B. Could I split all those snacks into 8 groups? Yeah, but we said we're going to have to cut the bananas. Yeah, so if you think about, these are all apples and these are bananas. If we split this into 8 groups, we get 1 apple and half of a banana. Because if we check, at least write a couple examples. So at least write the 2 groups and the 4 groups. You don't have to do the 8 groups, but here's why I would if I was you. The fractions are gonna mess you up on Khan Academy. You're gonna think about, I can do 2 groups, I can do 4 groups, but thinking about breaking things up and like cutting them in half or cutting them into pieces, this is what's gonna, like, you're gonna forget that that's an option. Now, the reason I say those things to you is I hope you don't forget, right? I'm saying that because I've realized in my few years of teaching that middle schoolers like to prove adults wrong, and I dig that. I'm down with that. That's sweet. So prove me wrong. Don't do the stuff I'm saying that you probably will. Like, that's my hope, right? So I tell you, you're going to fall in this trap door, and then I hope you don't. It's like when I tell my friend, hey, there's a mud puddle. It's like, I hope you don't step in it. If you do, I'm going to say I told you so. But... And we can check... What, the mud puddle? That means I'll probably step in one, actually. If we check the multiplication, 8 times A is 8A. 8 times half of a B is 8 halves, and 8 halves is 4. Guys, I will tell you, drawing the multiplication dot is optional, but drawing the arrows isn't really. Like, you need to draw those arrows so that you remember to do both multiplications. So I know we didn't do too much in Desmos because I'm kind of going fast. The next 2 that we need to practice because they're in Khan, and like this type gets harder, gets more difficult than the Desmos activity. Desmos is normally used for introduction. Check it. Write down these 2. The 2 at the top. Ooh, now you can't see them. Anyone need the distributive property or factoring anymore? I don't need either of these. Yeah, leave it here for a second. So you don't have to have the green part. I just want you to have the blue. I just said this is, some people were writing it like this. I just wanted to validate. That's correct. It's just not what we're doing today. So you can leave it. If you already wrote it, leave it. They're testing the system. I said when you came in here, they turned off they like cut the line. So now they're having to check, like, is it working? Yes. Yeah, if you can hold it, I would suggest holding it for a moment. But you can't. Like, I'm not saying no. If you need to go, go. All right, so our 2 problems here, we're going to start with negative r plus 8 times negative 5 minus 2. The arrows are not optional. So draw them. Oh my gosh, my camera. There we go. The arrows are not optional. Each arrow tells us to multiply. So hey guys, guess what? In 2 weeks, when you do your math notes check the next time, guess what I'm going to be looking for when I go to your distribution notes? The arrows. So please don't do the thing that I still am confused by and like set yourself up for failure. Some 7th graders want to test the waters and be like, I bet he doesn't care if I draw the arrows. I'm telling you, I do. Trust me, the kids in the past who get progressings on this stuff don't have the arrows. And I tell them, I told you, draw the arrows. So, the 8 distributes to both of these. And we have to do each multiplication, so I color-coded that. Right? 8 times negative 5r. Negative 40. You multiply the numbers, you bring the variable. Trapdoor is negatives, right? This looks like minus 2. But when we multiply with it, it's negative, because minus doesn't really make sense. If we're like, remember, it's either. Now, we could have started by changing this to plus negative 2. We could have started by changing that. Either way, a positive 8 times a negative 2 gets a negative 16. Sonny? Because we can't. Why? You tell me why we can't do parentheses first. Can I take 2 away from a negative 5r? Are they like terms? We cannot. That's a brilliant question, so I appreciate you asking that. Sonny's right. If we could, we should do parentheses first, but we can't. That's why I do the distribution. Nason.
I thought for you do 8 times negative 5r and then you do 8 times 2 and then
You'll get the same thing. If you're saying do 8 times 2 and bring it down as a minus, it's the same thing. If you're saying bring this down as a minus positive 16 is the same thing as negative 16. Remember, minus is negative. Negative is, remember with me? Because I can rewrite my final answer, and then Harish, I'm coming to your question. I can rewrite this final answer as negative 41r minus 16, and that is the same answer. Harish.
I thought you could multiply 8 times negative 5r because they're not like terms.
That doesn't matter. Can you have a banana and an apple, like, in the same bowl? Yes. Can you put a banana with an apple? Not really. It would probably be pretty messy. Can you have 5 bowls of a banana and an apple? Yes. We can multiply anything we want. We can also divide anything we want, because, I got like a karate sword at home. So we can multiply or divide regardless of like terms. Like terms only matter for addition and subtraction. So thank you for that question. Brilliant question, but that's why. Because I can say, what's a word that starts with R? Robot. I can say I have 5 bad robots, right? Negative 5 robots. And then if I have 8 groups of them, all of a sudden I have negative 40 robots, and that would be bad. If we have 40 bad robots, that would be no good. And then we have another bad robot, and now together we have negative 41. I'm scared. Now, the other thing I was going to say about like terms is I can have, this is going to get real weird. I can have a banana and $5, right? I cannot have these things to get, I can't put them together, but I could multiply them and have multiple banana and $5, right? But I can't, they don't go together, right? These are non-like terms. So this, who knows what it costs? This is like a variable. This is not, right? This is a constant. This is probably like 45 cents, if I were to guess. But who knows? Depends on the price of a banana. And the banana's price changes as it goes bad, right? Literally, if this was sitting in like a gas station, the price would go down as it gets old. So it's a variable. It changes. It's actually a decent example now that I think about it. 7N. Thanks, but stop real quick because we have 1 minute. This trapdoor comes from the fact that this minus or negative, whatever you want to call it, whether you call it minus or negative, I don't care. That distributes. It says we have 7N and the opposite of that group. So it's asking you, what's the opposite of 4N? Negative 4N. What's the opposite of negative 3? Positive. So guys, distributing the negative is one of the most dangerous trapdoors because people forget to flip the number around to the opposite. anytime we distribute with the negative, we have to make our values the opposite. And if you have all of that down, please wipe off your desk, and that's all the time we have. Regretfully. Have you guys seen the Bernie Sanders memes?